So in this video we're going to look at the specific fuel consumption, or to be more precise, the thrust specific fuel consumption. So the thrust specific fuel consumption is the amount of fuel that we need to burn to create 1 Newton of thrust. So it is generally the units given are kilograms per hour per Newton. And what it means is how much kilograms of fuel am I prepared to burn per hour for 1 Newton of thrust. So if we were comparing two engines, if we had a specific fuel consumption of 0.01, that means we're burning 0.01 kilograms per hour for 1 Newton of thrust, compared to an SFC 0.03, where we're burning 0.03 kilograms per hour to get 1 Newton of thrust. So, I suppose in the analogy of a car, it's a bit like miles per gallon. And we're looking for thrust-specific fuel consumption to have this as low as possible, because it means we're burning less fuel to get that 1 Newton of thrust. Now, normally, it's just referred to as SFC, specific fuel consumption. I'm just calling it thrust-specific fuel consumption because you can also have specific fuel consumption for a piston engine. And piston engines produce power. So it'd be the kilograms per hour per kilowatt of power produced. Where if I put the thrust, so the TSFC, thrust specific fuel consumption, it's more in keeping with a gas turbine engine, where we're producing thrust, which is measured in newtons. Okay. So if you look up engine facts, one of the figures that will probably be quoted is the SFC. Okay. So when we see it on a gas turbine engine, it really means TSFC, thrust specific fuel consumption, but most places will just quote it as SFC. So it's 0.38. If we look at the evolution of specific fuel consumption, you can see that from sometime in the 60s down to the teenies, the thrust specific fuel consumption is halved. In fact, it's more than halved, which is all very good for the environment and for fuel costs. If I look at an example, so if we look at the GE90 engine, and the GE90 engine is fitted to the Boeing 777. So if we assume that it's producing 200 kilonewtons of thrust, and it's burning fuel at a rate of 4 tons per hour in that one engine, then the thrust-specific fuel consumption will be, well, the kilograms per hour. 4 tons is 4,000, so it's burning 4,000 kilograms of fuel in an hour. It's producing 200 kilonewtons of thrust, so the TSFC is 0.02 kilograms per hour per newton. I've shown you this graph in other videos, but you can see over time, the bypass ratio has increased, and one of the effects of that is that the SFC has reduced, which is what we want. Okay, so that's what SFC is. It's the number of kilograms per hour per newton.